So I'll walk you through the complete data analysis on the PIMA Indians diabetes dataset using R. So here we load all necessary packages and read in the diabetes dataset. It contains like 768 entries, like with an outcome column showing diabetes status, like either zero, which is non-diabetic, and one diabetic. So this is to read and this is to load the dataset. So next, here the thing is some medical values like glucose or BMI can't realistically be zero. So we replace them with NA and remove incomplete rows. And after cleaning, we're left with 392 valid records. I'm going to So the structure confirms that 392 rows and 9 columns. And from the summary, we see average glucose is 123, average BMI is around 33, and age averages at 31 years. So here we are going to visualize the key variables. So are going to use box plots for that. First is diabetes. So this box plot compares glucose levels between diabetic and non-diabetic groups. You can clearly see that diabetics have like a much higher glucose levels on average, and the range also shifts upward. Um Coming to the BMI, so this plot shows that diabetic individuals also tend to be older with a higher median and greater variability in age. Um, like they tend to have like a higher BMI. Like although the distribution overlaps, the medium for diabetes is clearly higher. And like also in this, the diabetic individuals tend to be older with a higher median. Uh, so this is for like statistical testing. These t-tests confirm that the differences in glucose, BMI, and age between the two groups are all statistically like significant. For example, the average glucose for diabetics is 145 versus 111 for non-diabetics with a p-value that is like less than like it's like highly significant. So coming to the correlation heat map, this helps us visualize how these features relate to one another. Like darker blue means stronger positive correlation. You'll notice that glucose and outcome have a strong relationship, while BMI and age show moderate correlation. Like blood pressure and skin thickness is not there a weak correlation. So this guides our feature selection for modeling. And then coming to the principal component analysis, this biplot, one minute. So this biplot shows the first two principal components, which together explain about 51% of the data set's variance. Like each arrow represents a variable. Longer arrows mean greater influence. Notice how glucose, BMI, and age contribute strongly to PC1. So this confirms that they are good choices for modeling. So coming to the second question, we're going to see which models help predict diabetes. Yeah, so we use logistic regression to predict it. So all variables, glucose, BMI, and age are like statistically significant. So the positive coefficients show that higher values increase the odds of having diabetes. So the model has a low AIC of 362 and a well-fitted deviance. So the ROC curve evaluates the model performance that the model that we built. So it curves nicely towards the top like here showing strong classification power. The AUC is 0.8487, which indicates like excellent discrimination between diabetic and non-diabetic patients. So we have also used LDA, like linear discriminant analysis with glucose and BMI. So the confusion matrix shows 232 true negatives and 70 true positives with 77 overall accuracy. So it It's a solid classifier, but with slightly more false negatives than logistic regression. Um, and then we've used k nearest neighbors algorithms as well. So in this final one, I use KNN with k is equals to 5. Yeah, k is equals to 5. And accuracy comes out to 76.3%. It does a decent job, though performance depends on the choice of key and scaling. So, and it's also less interpretable than logistic regression, but it's still usable. Um, so to wrap up, glucose, BMI, and age are like strong predictors of diabetes. Logistic regression gave the best performance with an AUC of 0.85. LD and KNN performed slightly lower, but were like still effective. And visuals like PC and correlation heat maps helped us understand like the structure.